Just like it's kind of describing there. We got a suspended water fountain. Okay, description of it down at the bottom. Figure 1 shows a faucet, much like the one you turn on a spigot outside your house. Okay, it's floating over a large cup. Okay, water flowing down into it. Stream of water coming out of the faucet, flowing into the cup. Okay, so as I was going through this and doing some digging, okay, there's a connection here with fountains, because the second diagram you got in there in your packet, there's hollow fountains. Okay, so there's a suspended fountain, like this was titled, then there's a hollow fountain. Okay, in my curiosity, I had to Google everything. It's like, well, what in the world's the difference? Okay, if they're talking fountains, well, I know what a fountain is. You guys know what a fountain is. Okay, it's those decorative things. Okay, that water flows out of. Okay, we kind of caught Brittany by surprise out in the hall because Miss Silflo and I were talking about the water of a fountain. In a decorative fountain, what's happening with the water? It's what? It's recirculating. Well, recirculating. And she thought we were talking about the water fountain down the hallway. It's like, yeah, I'm never drinking that again. Yeah, okay, so there's a difference, obviously, right? That's fresh water out of the water fountain. Decorative fountains, recirculating, recycled water. Okay. And so this thing, I had to Google some differences with fountains. And I don't think you guys have to construct a fountain. That's not your performance task. Okay? But it's understanding some terminology. Okay, so with this suspended water fountain idea, my Google search brought me here. To some actual art out there in the world. There's a suspended water fountain out there. They call them magic tap fountains. This one's in Belgium. Okay, pretty cool.
There's a hole in the water. Yeah, there's a clear.
Okay, we've got that one, Menorca, not familiar with that. Okay, but again, kind of cool. You look at the water flowing right there. Okay, you got that baby in Spain. Okay, so again, kind of a suspended water fountain idea. Okay, obviously they're out there. They're out there in the world. Okay, there was 3 or 4 of them, I think, in existence. Whoop. And so that leads us back into this. If this is a suspended water fountain, okay, one key question somebody brought up: how is it standing? Austin, what'd you say there? Yeah, I mean, there's got to be some sort of hole sitting in there. Okay, clear probably. Okay, that's can't be seen. Okay, so water's flowing. Okay, and it appears that water's running. Okay, so how do fountains work? What's the key pusher of water?
Gravity.
What's it need? Maybe gravity. Yeah. What else?
A pump.
Mike, what's that?
A pump.
It needs a pump of some sort, some water pump. Okay, getting water. Yeah, it's pumping water somehow. Okay. So again, I don't know if they're really wanting you to visualize a water spigot in this case, just water flowing out of a spigot. Okay, or if they truly want the fountain idea. So if it is a fountain idea, obviously it's got to be, got to have a tube in the middle of it. Okay, so it's actually fountain stuff. Okay, go ahead. Now with this, stay on this page. Okay, so again, they're not going to ask you to construct a fountain, obviously, but what kind of math could be involved here? What kind of math topics? What do you think? Yeah.
Geometry.
Okay, some geometry things, obviously. Okay, we've got, first of all, this receptacle where water's sitting in there. You could possibly figure out how much is in there. What's that geometry term? Volume. Yeah, maybe there's some volume topics. Okay, now that's kind of tough because that's not a cylinder. Okay, it's not actually a cone, which we have formulas for. Okay, but there could be volume topics. Okay, yesterday in geometry we had a worksheet. that dealt with rates. Like gallons per minute sort of idea, okay? So maybe they're going to tell you the volume of this fountain, okay? And they're going to say it's, flowing this many gallons every minute, okay? And then you come up with a rate, okay? I'm just guessing here, you guys, what kind of math topics are going to be there, okay? But that seems kind of where I would head, okay? Volume ideas, rates, okay? There's no guarantee that's what's there, but that's kind of what I see from that, okay? Go ahead and go to that second page. Okay, now they're tagging this to the hollow fountain idea. Again, in my curiosity, I was like, well, why in the world do they got a spigot on top of that if it's a hollow fountain? Okay, and so again, I did a search for what hollow fountains would bring up. Okay, the suspended fountain amazed me. Okay, and the hollow fountain, kind of like something you'd see in Vegas maybe. You got those things at the Caesar's Palace, okay, up in the air. Those are fountains, okay, hollow fountains. No spigot on top, obviously, okay. But again, it's probably with a tube, water shooting out of it. Okay, you just got that idea of that hollow fountain. Okay, I think the key point that they want you to understand on this performance task is the hollow aspect of it. Okay, whereas that other suspended fountain, the full cup was there, that receptacle, that container. Where is this guy? That's the hollow portion. Okay, that's not actually filled with water. Okay, the water level is only at in a certain area. Okay, what are the advantages of that, possibly? Yeah.
You do a lot of shows with the hollow ones where they shoot out of the ground and they do different, they'll do it to beats and things.
Yeah, it could be, the other one's probably more of a continuous thing. This could be, like Austin said, could be set to music, okay? Shows happening, okay? It's maybe more controllable, okay, in this aspect, okay? It could conserve water maybe, if that's, don't have to use as much water to fill the fountain, okay? But again, I think the difference between the two is just know that one's hollow, there's space down below where the water sits, okay? And then the other one's not. Okay? So again, same types of math. Volume, flow, okay, rates of flow. We're good. Okay, go to that third page. Okay, I do my best. I'm a little teapot, short and stout. Here's my handle, here's my spout for you, but okay, I won't go through all that, right? We all know the song. Okay. So the whole idea behind this thing, it's called the Great Coffee Cup Activity, okay? And so, again, you got probably questions wandering through your head. How are fountains and coffee pots and coffee cups all related? Let's give you a big shrug. I have a conclusion at the end, but we'll see. Okay, so a couple things about this. Figure 3 is a picture of a coffee pot. Got a coffee pot. They call it a bulb container. Okay, so if they use that word bulb, when a bulb pops into your mind, what do you think of? What? A what? A what? Who? Somebody said it. What? What do you say? A light bulb. Yeah, a light bulb has that curvature to it, kind of like that coffee pot has the curvature to it. Or maybe it's a flower bulb you put in the ground, you have that curvature to it. Okay. Again, if you have to run through that song, I'm a little teapot, to figure out which one's the handle and which one's the spout, that might come in handy, right? So water pours out of the spout, okay? You hold the handle, all right? So coffee pot, we're good. Now, identification of parts of the coffee cup. You look at part A, we'll just go through this in alphabetically. Part A, the top, circular shape, edge of the cup. I think another name for that is. Where's Michael heading? He's where? Heading to the what?
Rim.
He's heading to the rim. Okay? Heading to the rim. Okay? Okay? If they reference rim on the test, okay, with a coffee cup, know that it's that area. Okay? It's that area of the cup. It's okay? Part B, bottom of the cup. It's sitting
Base.
on its base. Yeah. Okay, so they might refer to the base of the cup. Okay, mathematically speaking, what are some things maybe that flow through our head? What about the rim and the base?
Parallel.
They're parallel. Okay. Okay. The rim's parallel to the base. Okay. Size-wise, what's bigger? Probably the rim's going to be bigger than the base. More than likely, if it's a cup, like your standard coffee cup, the rim's bigger than the base. Okay. What shape are they?
Circular.
Okay, circular. So what kind of things, circle-wise, pop into your head?
A ball.
Okay. Circular. Again. Circumference. Circumference. Mathematically speaking, okay, maybe there might be some circumference topics. What else? Radius. In order to do circumference, okay, the whole idea of radius and diameter come into play. Okay. Maybe areas of circles, possibly. Okay. Could be scale factors. Top circle might be twice as large as the bottom circle. I don't know, again, I'm just guessing, you guys. Okay. But it's things you gotta kind of keep in your head. Okay, what are you expecting to see on this? I don't know. You kind of have to have this broad picture of what they might ask. Okay, but usually if it's circular based, okay, those are pretty good topics. Okay, radius, diameter, circumference, area. Okay. All right. Part C, side of the cup. These blanks are closing in on me.
Walls.
Yeah, okay, that's a wall. Yeah. So again, for identification purposes, and if they use this terminology, okay, the wall of the cup, you know where that's at. The rim of the cup, the base of the cup, okay, it's all there. And again, it's all speculation on what kind of math topics they're going to be asking. Okay, but mostly it's an identification of thing. You've seen some fountain ideas, coffee cup ideas. Now this is the connection I guess I made. If I were to grab that coffee cup or coffee pot and pour it into the cup, does that look like that first suspended fountain, kind of? Kind of, yeah. I don't know, that was just my guess. I don't know. So as coffee's pouring out of the pot into the cup, it kind of has that fountain effect. Okay, yeah. So again, your guess is as good as mine, how they're going to tie all this stuff together.